Hello, this is the second surface development tutorial, and in this one we'll be learning how to do two different parts that are merging into each other. In this tutorial you will be given a file. The file name is figure 23-31. Once you load the file and open it, make sure you save it in the place where you keep your work, just to make sure you have this working file as a backup. And we'll begin. This very beginning part, I'm going to turn off the grid because I don't like seeing that in the video. It doesn't look very nice. So I'm also going to insert the example of the problem. Attach. One, two. Now this portion here you do not have to insert into your drawing. This is just so that we can work with it on the video. I can keep not have to reference flipping screens. We will notice a little bit of differences in the file that is given versus the file that the drawing, the assignment. If we look at our L6, it's located at the very bottom of the polygon. It intersects with that line. And if we were to cut that out of paper, it would end up falling off. So to make your life a little bit easier, what we've done is we've moved the triangle that's intersecting the pyramid shape a little higher so that it's not intersecting, which creates a new point, 0.8. And that's why one of the reasons why we made sure we gave you this file, which is already done for you now. Now what we're going to do is we're going to take the information here and turn it into a flat surface development. We'll start with the surface development of the triangle, and we'll move on into the pyramid. So now we can begin. We'll start by projecting line work from the pyramid, or from the triangle over. Doesn't really matter how far over it goes right now. Just going to project some line work. Then I'm going to have a line that crosses across here. This line here is going to be the edge of the triangle. To begin with, we'll have our L right here, L6 and 6L. I'm going to use the trim command to cut these away. Now to find the distance from L to M, I'm going to use the information from this triangle and draw a circle radius from L to M. I'll bring that circle to L. To know this is L, it's helpful to label as you work. Gives you references for where things are. And so if we're following the straight line where this circle intersects, that will be known as M. I'm going to draw a line for M. I can also label both sides. It's not necessary in this final drawing, but for simplicity's sake, so I could reference things, I'm going to do it just to show you more information. All right, so the distance from L to M is now the same distance from L to M here. You'll notice on this view, L to M is foreshortened. And that's why this view is untrue. But this is true. And notice that it's straight instead of on the angle. That's one key factor of wanting to lay it flat. Next, we want to go from M to N. So we'll do a circle from M to N. And then we'll draw a line. And label. Next, N to L. I'm going to remove the extra. Excuse me. Now you'll notice that I have two L's. This is where the seam L will meet up when it's folded together, creating that triangle shape. So at the end of this, we will end up with two different L's and two different sets of sixes. Speaking of which, let's go ahead and project that now. We'll bring our reference point 6 and project it straight across. And I'll trim out the excess line. And I can remove my projection. So now this is now 0.6. Bring these sixes over. M intersects with 1. So I'm now going to project my 1 across. And then I can trim. And then label. Now, in the examples we've done so far, the numbers have been intersecting with the letters. In the case of 2, 5, 3, and 4, they don't intersect with M, L, or N. So we have to get a little creative with that. Since we're using the triangle as a true flat distance, even though 2, 3, 4, 5 do not exist on that line, we will project it from the edge of the triangle. For example, let's take from M to 2. I take the circle from M to 2 and I place it on M. That tells me where line 2 should go. And I'll draw line 2 here. Just to know this is a projection, I'm going to change this to the ano layer so we don't get confused that as a fold line. This is just a projection line. Anything that's an ano is just for projecting and finding reference points. And then with that, I can then project my 2 across to hit projection 2. And then with that, I'm going to change, well, I'll keep on drawing with this. My 6 to 1 and my 1 to 2. I'll do the same thing on the other side. And that now gives me the reference points for 2. So I'm going to label. Move that circle. That indicates that is line 2, and these are the points 2. All right, now erase my projection. Next, let's find 3. Take a circle from M to 3. Place it on M. Now, I could have also have done the distance from N to 3. And if this is all done correctly, then they will both hit the same point. Just for reference. So I know I'm being accurate right now. Now I'll project my 3. And notice I only have 1 point on the 3. Because that's the very top of the triangle intersecting the pyramid. So on this side, we're pretty much complete here. So I'm going to do some little cleaning. Make sure I bring my 3 over. Bring it up and down. We'll also make sure this is ano. So we know that it is not a fold line. Next, we'll find 5 and 4. We'll go from L. Placing it on L. And then we could draw our lines. Turn them to ano. And then label. I'll project our line work. So 4 here. 5 is here. And here. And then we'll connect our points. 6 to 5, 5 to 4, 4 to 5, and 5 to 6. Remove my projection lines. Now for the majority of this is now finished. Let me go ahead and make these object layer lines. Now, if we left this as it is now, this triangle would be hollow. For example, the surface MNL would just be a thin piece of paper, and this would be like a hollow hole going into the piece. So we want to solidify that and put a surface on that face. Even though on this it doesn't show it, we're going to add it as well. And to add it, it's not that hard. all we have to do is do a circle work. From N to L. And M from N to L. And with that, both of these circles going to L ends up creating a new L. From M to the intersection, and from the intersection to the N. I'm going to delete these circles. This is the new L. Make these object. Now you can see NL and NL here are the same length, and that ML and ML are the same length as well. They will attach together. This is where the seam will go. We'll do the same thing on the opposite side, just to review. Now you could mirror this, but I'm going to show it to you again. M to L, N to L, where those two circles intersect. That ends up creating your triangle. Yeah, I'll change that to a solid. And let's go ahead and save. Because this right here is pretty much complete. We'll come back and add some tabs later. But next we'll go ahead and get started with the pyramid. To begin, we'll start with a circle from 0 to D. Notice that A is also the same length. Because this is a polygon, all sides are equal. On this view, the distance from 0 to D is foreshortened. But on from 0 to D, it's true. But because it's a front view, you'll notice that 0 EC and 0 FB are shorter than this circle. That's because they're also foreshortened on this view. We'll need further information for this later, but I just wanted to make that apparent to you now. But this is the true length from 0, the very top is the center of the circle, to D. We're going to take this information. I'm going to move it over to here. We could start our first line from the bottom quadrant to the center, or vice versa. And this is going to be known as 0. Okay. Now, on this view, D to EC, or A to FB, is foreshortened. FB and EC are true, but it's a little bit more difficult of an area to work with. But on here, all the sides are equal. So what I'm going to do is do a circle from D to C. You'll also notice that it hits E. EC share the same point in the front view, but they're on opposite sides. This is the true length from D to C and from D to E. I will take this information here and place it on D. Now I could draw from the intersections to 0 and then back, complete my circle, and I could label accordingly. So now I have point C and E. It doesn't matter which place I draw the circle on, if I want to draw it from A to B or C to B, it'll all be equal. So what I'm going to do with this circle now is I'm going to place it on each point that I get to find the next one. And I'll copy. I can erase these two. Now, this one, C to B, and E to F. Both end up going to A. So I end up getting 2 A's. And because I have these 2 A's, that means this is going to be my seam for the pyramid. So my seam will be going across here. I can now remove this circle. And then I'm going to use straight lines to connect. All my lines. And I'll change these all to object. Now, you'll notice that some of these lines are broken. A to 0 is broken because the triangle intersects at 3 and 4. Now, because 0 to A is a true length, I can use that to draw a circle from 0 to 3 and a circle from 0 to 4. Make sure I don't have any intersections there. Remove these. Then I can trim. And then label. 3 is closest to 0. And 4 is closer to A. And there's the break where the triangle would be inserted. Now, in order to get 2 and 5, because we're on a front view and the lines are all equal, we can project 2 and 5 across to D because it's at the same height. And now we can find out what the true length from 0 to 2, but this is just any 2. This is 2, 1. Now, you do not have to label this. It's not that necessary. But just so you can see what it's referencing in the book when it mentions the 2, 1. Now, 1, 1 does not work. Do not use 1, 1. I will show you when we get to finding the point for 1M. We'll work on that together. But at this point right now, don't worry about 1, 1. But we will project this across. Oops, this one. Already have it projected. It's 5. Copy this over. we have intersection 5, 1. With that information, we'll take a circle. From 0 to 2, 1, and 0 to 5, 1. Take those 0 circles, put them on 0. And since it's cutting BF, that's what we'll do. 0B and 0F. And then we will label it. Just doing a little bit of cleaning. Fix that later. Okay, so we now have 2 and 5, 3 and 4. Our last number is going to be 6 and 1. But before we can get those, we have to make these projection lines on the triangle. 0, 7 and 0, 8. To get them, we'll draw a circle from F to 8. And I'll put that on F and B. Just clean that up. Be very careful about extra snaps. Because one wrong snap could mess up your drawing. All right, that's 8. So I'm going to draw an anno line from the intersection here to 0, and from 0 to the intersection here. And now from EC to 7. C, E. Then we'll draw our line at the intersection. To the intersection. And I can erase any extra lines and the circles. Let me label. This may get a little confusing. 8 is closer to B. Turn myself off just so don't get 8 and 7 confused when you're putting on your flat piece. Like I was saying earlier, we could also mirror this. Where's those wrong? And 8 is closer to F, which is true here. Now, these lines are on a surface that is foreshortened on both views. So in order to get the information for where the points are, where 1 and 6 are, so we're going to have to draw little triangles off to the side. First things first is we're going to take the height from 1 and the top distance from 7 to 1. And then from that information, we have a triangle. And this is our true length. So now we take a circle from here to here and place that on, that was 7. And where this intersection happens here, that is 1. And 1 connects to 2. Let's mirror that. Mirror the 2. And the information around here. Also mirrored 5. So this can now be labeled as 1. Now 1 connects to 6, which is on 8. So in order to do that, we're going to do the same triangle trick again. We're going to take the height and the top distance from 8 to 6. And make our triangle. Notice that I'm going to the quadrant to make it nice and straight. And that's the true distance from 1 to 6 and 5 to 6. And I'll mirror. Should label my 6 first, a little faster. Okay, let's change these to actual lines. It's not using ANO anymore. Let's go to Object and finish this off. Let's save. Now, if everything was done correctly, you could take measurements from 1 to 2. And 1 to 2 would be the same here. And 1 to 6. So that means when you print this out and you cut it out, you put it together, these sides will all match. 6-1 will match 6-1. 5-4 will match 5-4. 3-2 will match 3-2. And that's how you will combine the piece to make it look like this. Now, in the classroom, we would normally go ahead and print this out with tabs and cut it out onto some cardboard paper and fold it, cut it, and put it in there. This video may be used during a time when we're back in class. So we're going to put the tabs on as well. And if you at home want to go ahead and print this out and do the same thing, test it out, try it out, see how it works, you're more than welcome to. So we're going to need what is called tabs on all the points that match, that will be going together, but only on one side. So for example, let's go ahead and draw this in ANO. Turn ortho off. This is more artistic than anything. (6L) will attach to this 6L. So I only need a tab on one side. This 6L will also need to attach this 6L. In this case, I'll take the tab and I'll just mirror it. So it's on this side. And now this 6L will be able to attach to this 6L. Our little flaps that we have here also need to have tabs on them. I'll put a tab here. Now where you put your tabs is your own business. If you decide you want to have the tab on this side instead of on this side, you're more than welcome to do that. That changes it up. It just gives you something to tape or glue the pieces together so that when you're putting it together, it is easy to do. Also, the size of your tabs may vary. As I was saying earlier, it is like an art form. It just needs enough material to attach here. In the industry, these could be welds or they could be clamped. The method to building these can vary in the industry. But for now, we're just doing a paper cutout. And now this 6-1, this 6-1, this 2-1-2, this 2-3, this 3-2. I'm going to connect to all these. So I usually recommend putting the tabs on the inside. Just to make them small and out of the way. I didn't have to draw these. I could have left these out and just mirrored them. I just got into the swing of things. Sometimes you get involved with doing little drawings and you just keep on clicking. This one I gave a little bit more of a sharp edge because it was going to be going attaching to this side. There's not a lot of clearance here. The bottom is going to be hollow. It will give you room to maneuver your fingers into the piece to tape it down and attach all the different sides. Once you have this the way you want it, lay out your sheet. Typically, we print this out on an A-size sheet of paper. Let's try this in portrait. The scale for this doesn't matter as long as it's uniform with the drawing. What I'm going to do is a zoom window. Z-O-O-M W. Nope. Just do zoom. Enter. Once I have that, I have the window option. And I will just draw a window as approximately as close to the piece as I can. Oh, that's a little too close. Zoom window. I could move this a little closer to get a little bit more zoomed in, but for my example, I'm not going to worry about that. You will do your best to get the fit in as you can. And then what you'll be able to do is print this as is. This is not to scale. So if you do need to turn this in, sheet 1 of 1, the project, the scale, but not to scale, and then your name and the date. But in the classroom, you'll take this, print it out on cardstock, and cut it out, and then put it together. This has been your figure 2.3-31 Surface Development 2 tutorial, and I'll see you in the classroom. Bye-bye.